Mute on. Mute on.
All right, it's about 5 after the hour, so we'll go ahead and get started today. I'd like to go ahead and thank everyone for joining our session today on VMware Cloud on AWS, NSX Networking and Security Enhancements. My name is Corey Sharman. I'll be your host today. I am the Senior Technical Alliance Manager with the VMware TAP team, and our presenters today are going to be our Technical Product Manager over NSX, Humair Ahmed, and then also assisting Humair with questions today is going to be our Senior Product Line Manager, Vyenkatesh Deshpande. And any questions that any of our partners have, you can go ahead and type them into the chat window at the bottom right-hand side of your screen, and we'll make sure and go ahead and address any questions that you have throughout today's presentation. And with that being said, Humair, I'll go ahead and hand it off to you. Thank you.
Okay, thanks, Corey. So today what we're going to do is we're going to talk about VMware Cloud on AWS, and specifically we're going to focus on the NSX networking and security enhancements that we made. So a lot of content here to cover, so let's go ahead and get started. And taking a quick look at the agenda here, we're going to start with level set, intro, use cases, and then talk about how we're changing the underlying platform to NSX-T SDDC and a lot of the features that are coming along with that. We'll go into a deep dive on those features and then show an interesting demo as well, wrap up with a summary. So with NSX, really the goal is we have this virtual cloud network, and what we're trying to do here is really make sure we can connect and protect your workloads regardless of where they sit, right? So whether we're talking about, on-premises, cross vCenter, NSX, AWS, in this presentation, we're going to focus specifically on VMware Cloud on AWS, but the goal is really to protect your workloads regardless of where you sit. Now, again, we're focusing on NSX networking and security and VMware Cloud on AWS specifically for this session. So in regards to VMware Cloud on AWS, what are we doing here? Well, we're taking the full VMware stack, vSphere, vSAN, NSX, vCenter, deploying it on bare metal hosts and hooking it up to the AWS global infrastructure, right? Now, you also have data centers right on-prem, and we provide different connectivity options between the on-prem data center and this SDDC in the cloud, including hybrid link mode where you can centrally manage vCenter both on-prem and in the SDDC with a single pane of glass. And you can also take advantage of all the management tools you're used to using, right? We have vSphere both on-prem and vSphere sitting in the SDDC. In addition to that, we have worked together jointly with AWS to provide capabilities where from the VMware Cloud on AWS SDDC, you can access native AWS services like EC2 instances, S3 buckets, and so on. And one thing to really take away from this slide is the NSX is providing all, looks like there's some, maybe we mute everyone else?
Yeah, sorry about that.
Okay, so here one thing to take away from this slide is the NSX is providing all the networking and security within VMware Cloud on AWS, and also providing connectivity services to on-prem, and then also to those native AWS services sitting in connected VPC. And we'll talk about all this in a lot more detail. Okay. So really quickly, let's just look at kind of, what we're doing in terms of how this works, VMware Cloud on AWS. So there's the VPC networking. This is the AWS VPC networking. We're deploying bare metal hosts, and we're using AWS ENAs to connect those hosts to this overlay of AWS. Now, those of you familiar with vSphere you're familiar with VDS, and basically with VDS, we use VLANs for a couple of reasons: to segregate traffic like management, vMotion, so on, but also to provide consistent networking across all hosts. And an interesting thing here is AWS is, we're running on AWS overlay, so we have to have some kind of mapping between these VLANs, right, to that overlay. So we do some VLAN ENI mapping to get all of this work so we can deploy this VDS, right, which leverages those VLANs and provides that consistent networking across all the hosts. So we do this VLAN to ENI mapping, and you can think of ENI as basically interfaces connecting to that VPC networking or that AWS overlay. Okay? So really, that's all abstracted away from what customers or from those users who are using VMware Cloud on AWS. What's important to customers is, okay, what do I get through the portal and how do I deploy this? So you go to the VMware Cloud on AWS portal, you deploy your SDDC, okay? When you deploy your SDDC, a number of things happen automatically in the background, right? All this stuff gets deployed for you. vSphere, vSAN, NSX. Now, and all of this gets deployed and configured. Now, in respect to NSX, some additional things get done where edges are automatically deployed. The distributed logical router is deployed. Default networks are deployed. We also have a default route automatically going to the internet gateway, so your workloads have internet connectivity. Then you can, do additional stuff like do NAT, DNAT, and also place additional firewall policy on the edges and so on, right? So you get this secure environment right away. Again, click of a button, you deploy your SDDC, all of this gets deployed and configured, including a default network, so you can automatically have this secured environment and start deploying your workloads right away. And that's really what's important, right? To go ahead, get this thing done, get everything already deployed, and just start focusing on your workloads. Now, you have connectivity to on-prem, and we provide different services and options there as well, including IPsec, L2 VPN, Direct Connect. And again, we'll get into more of the details later on. And again, we also provide connectivity to the connected VPC where you may have native AWS services already running, like EC2 instances and S3 buckets. Okay, again, this was through some joint work done between VMware and AWS, and we'll get into more details on this. So now that we have a good overview of what VMware Cloud on AWS is and some of that functionality, let's talk about some of the use cases. So here we have, on-prem data center. So one of the primary use cases is simply data center extension and moving workloads to the cloud. Right, we make this really easy for you because, again, you're using all the same technology that you're already used to, vSphere, vSAN, NSX, right? We deploy this in SDDC for you in the cloud. Another benefit here is you can instantly get a global reach. So you can deploy an SDDC here at my on-prem is in Palo Alto. I deploy one SDDC in US West Oregon, another in US East North Virginia. I can deploy SDDC in London or Sydney or many of the locations we already have, and we're constantly expanding, right? So data center extension. Second use case is on-demand capacity. You may be running low on capacity on-prem. Well, you can simply click of a button, deploy VMware Cloud on AWS and SDDC, and then you can leverage the different connectivity options, IPsec, L2 VPN, Direct Connect, and deploy those workloads in the cloud. Third use case, migration to the cloud. So you may have workloads on-prem. Either you want to move some of these workloads, or perhaps you want to do a complete data center evac and move everything to the cloud. Again, click of a button, deploy SDDC in the cloud, leverage the different connectivity options we have, whether it's IPsec, L2 VPN, Direct Connect, and we support both cold migration, and then with Direct Connect, we also support live migration or vMotion to the cloud. Okay, another use case is disaster recovery. So I've worked on disaster recovery on-prem for a number of years, very popular use case on-prem with NSX, and I see it that it's going to be just as popular in the cloud. So here, again, we want to do disaster recovery to another site. Only difference here is that other site is sitting in the cloud. So you have your on-prem environment, you deploy SDDC in the cloud. Again, leverage that capability we have in terms of the connectivity options, IPsec, or if you want to maintain the IP address, consistent IP address, you can also leverage L2 VPN, Direct Connect, and now once you have this connectivity set up, you can enable site recovery, you can enable this add-on, and what will happen when you enable this add-on is basically SRM and vSphere replication get deployed within the SDDC, and you can download those components and also configure them on-prem to configure this replication, and then you can set up your disaster recovery plan. Now, when a disaster happens on-prem, your disaster recovery orchestration tool, in this case SRM, will recover those workloads in the SDDC in the cloud. Okay. All right, so now we have a good understanding of what VMware Cloud and AWS is. We understand the use cases, and what I want to dig into here is some of the architecture and changes with NSX-T SDDC. Okay. So first, when we launched a service, VMware Cloud on AWS, the underlying networking and security platform was NSX-V, providing all the networking and security. And this, we basically had management pool and compute pool. And management pool is, basically consisting of vCenter, NSX Manager, NSX Control, NSX Edges, basically everything VMware manages, right? And services provided here are provided by the MGW. There's things like Firewall and VPN, NAT for public vCenter access, and also DNS capability. There's also a compute pool, and this is where the CGW and distributed logical router are deployed. And here, we have a very prescriptive network topology you can see. There's one MGW, one CGW, one DLR. When networks are deployed, they're automatically connected to the CGW. DLR is the gateway, right? Very prescriptive topology, and default network segment is also created, but customer can create additional network segments as well. There's DHCP functionality, and also firewall and VPN here as well, and NAT for VM internet access can be configured as well. In addition to DNS and connectivity to the native AWS services. Okay, now with this release, there's a lot of benefits already, right? You get protection for your application through north-south firewall, allow connectivity to application from internet. For example, you can request a public IP and use that to give access to your workloads sitting in the VMware Cloud on AWS SDDC from the internet. And you can the ability to create on-demand logical networks, right? You could also get secure hybrid connectivity through policy-based IPsec VPN, can access the native AWS services, and there was a single pane of glass with for management with vCenter hybrid link mode. And then we also supported both cold and live migration. So this was all there, and we already had a lot of benefits with NSX-V SDDC. I want to dig into a little bit about the access to the native AWS services here. When you deployed your VMware Cloud on AWS SDDC, basically you put in the account ID of where you have your EC2 instances, S3 buckets, basically your native AWS services running. And what would happen here is basically a number of VNIs get created in this native account, and they get attached to hosts in this in the VMware Cloud on AWS SDDC. Okay, And that ENI connectivity is what's used to access the native AWS services as well as instances here to access workloads sitting in VMware Cloud on AWS. And what happens here is basically the route tables in AWS via API calls are updated to point to the network sitting in your VMware Cloud on AWS, to access these networks to go over this ENI. The route table here is updated, and vice versa. Route tables are updated via VMware Cloud on AWS SDDC to go out and leverage this ENI connectivity to access these native AWS services. Okay, so that's how that works, and that functionality is pretty consistent, remains the same with how things work when we change the underlying platform to NSX-T, which I'm going to talk about next. Now, there is some additional benefit with the NSX-T architecture, but for the most part, how this works remains the same. So now I want to talk about, the changes coming with the NSX-T SDDC. Back in July, we announced that AWS Summit in New York that this NSX-T SDDC was available in preview mode. And basically, there's a lot of new functionality coming with this architecture change. And that's what I'm going to step through in the next couple of slides. So here for the CGW and MGW, you can see it's very consistent with what we had with the NSX-V SDDC, right? You still have CGW, MGW. Key thing to note here is in NSX-V, these were CGW and MGW were each VMs that were separate appliances. In this architecture, we're leveraging NSX-T for the underlying networking security platform. This is all just one appliance, the CGW, MGW, and then they're connected via another router. So in NSX-T terminology, the CGW and MGW are T1 routers, and these have an edge component, and they also have a distributed component. The T1 router is a distributed component, and it's sitting on all the hosts. And you can think of that distributed component here for the CGW across all the hosts, similar to the distributed logical router in NSX-V. And again, the edge components sit in this edge appliance. And another difference here is CGW and MGW are no longer VMs. They're processes sitting in one edge appliance that they're connected together via another router, which in NSX-T terminology is called a tier 0 router. Okay. So this is basically the architecture with NSX-T. A couple additional differences here are, this edge is DPDK based, so we'll have better performance. Also in the ESXi host instead of VDS, again because of NSX-T, we're using NVDS switch on the ESXi host. And another key thing here is since the CGW and MGW are connected via tier 0, they can automatically, via the architecture, talk to each other. And I'll talk about later on how there's some benefits to that. In NSX-V architecture, this wasn't possible. You could do a workaround where you had to create VPNs between CGW and MGW, but it wasn't efficient, wasn't the best design. Now this is supported natively with this architecture change. Also, we have since we have a tier 0 connecting CGW and MGW, we no longer have to do VPN tunnels to CGW and MGW separately. We can do one VPN tunnel to the tier 0, which then knows how to route to the networks beyond CGW and MGW. Another difference here in terms of architecture is this vCenter management network is now also sitting on an overlay, okay, just like the compute. And there's some benefits to that as well I'll talk about later on, okay? So in a nutshell, that's the architecture change in terms of from NSX-V going to NSX-T, okay? Now, I want to dig in a little bit more to some of this underlying changes and some of the benefits that come along with that. Now, the important thing to note here is I'm mentioning this because I want you to understand some of the changes we did and some of the benefits it actually provides to end users, right? But really what's important here is the features and capabilities we provide through the portal and the front end that customers and users will be using, right? But let me just go through this real quick before I jump to that so you can understand, just by changing this underlying platform, network and security platform, some of the inherent benefits that you receive. So first, the vCenter management network, as I mentioned, is now on an overlay, okay? So what this means is similar to how compute behind the CGW is on an overlay, now the vCenter management network behind the MGW, again, behind the MGW is everything we manage, is also on an overlay. And what this means is you can use the same operational and troubleshooting tools now that you use for compute for this vCenter management network as well. Okay. Another benefit is workloads behind CGW can talk to management components behind MGW via the tier 0. Because we have this tier 0 now connecting the MGW and CGW workloads, hit this T1, CGW T1, go up to the tier 0 and can go down to the MGW and access vCenter. Again, no workarounds needed where you have to create VPNs between CGW and MGW. This is provided natively within the solution now. Okay. And why might you want to do this? Perhaps you have like automation workloads running some kind of automation, calling API calls, sitting on network segments here behind the CGW that need access to vCenter, or some kind of monitoring appliances. This is now possible. Another benefit is ESXi, direct ESXi host access from the overlay. So again, because we're connecting via the tier 0, these workloads sitting on these network segments can come up to the CGW, T0 down to the MGW and access the ESXi host. And why might a customer want to do this? Well, again, they might have tools running on these network segments, something like, say, Plixer Scrutinizer or a Wireshark where they're doing port mirroring. And what happens is these tools leverage functionality where the hosts, or here the ESXi hosts, are doing port mirroring, or where you have IPFix enabled, and it needs access. Those tools need access directly to that host where that port mirroring and that functionality is enabled, right? It needs to be communicating directly to those hosts. Well, now that functionality or that communication is possible with this underlying change. Okay? And actually, you'll see later on how we leverage this to actually provide you functionality like port mirroring and IPFix in this release. Okay, so now another benefit is vCenter management network access directly from workloads that you might have sitting in native AWS connected VPC. Again, here you might have EC2 instances that perhaps need to access vCenter for either maybe some monitoring application or calling APIs. Well, when it comes, hit this tier 0, go down to the MGW, and then we can now access that vCenter management. So before we were only updating the route table in the connected VPC with how to reach the compute workloads. Now we also update the route table here on how to reach the vCenter management workloads. And then finally, we also made some enhancements here with the Direct Connect, where all traffic is now supported over Direct Connect private WIF, which terminates directly into the VMware Cloud on AWS VPC. So before, with NSX-V architecture, the only traffic supported over Direct Connect was ESXi management, vMotion, and cold migration traffic, and all other traffic like compute or management appliance, we had to create separate VPN tunnels either over internet or Direct Connect public WIF. So the designs were, it was possible to get customers doing that, but it was a bit more complicated, and what customers really wanted was they wanted all this traffic to go over Direct Connect private WIF, which terminates directly into the VMware Cloud on AWS VPC. Okay. So you can see there a lot of benefits just by changing the underlying platform that we're doing, right? Going from NSX-V to NSX-T architecture, right? Now, In terms of the GUI, we also made some changes here. So what you're seeing on the screen here is the layout, how it looked with NSX-V SDDC. It was vertically based, where you kind of scroll down from management gateway to compute gateway, and you could configure the respective things that needed to be done, like L2 VPN, firewall rules, NAT, and so on. Now, we had a lot of feedback from customers where, we wanted to make this easier to manage and configure the respective security, networking, and so on. So we moved everything to the left here under the Networking and Security tab, and you can see we have groupings with network, security, inventory, tools, and then system. So, we had a lot of feedback from customers that this design really made it easier to kind of go to the respective sections and configure what needed to be done. Now, one thing to note here is, there's a lot of functionality that comes with VMware Cloud on AWS in general, but then there's also supported add-ons, right? So things like DFW, and then in the future, service insertion, load balancer, all of these are going to be part of the advanced services add-on, okay? So customers will get, a lot of functionality here in general, edge security, being able to create network segments, VPN, security groups, IPFix, port mirroring, that's all included. And then they can enable additional advanced services add-on, which will include DFW, service insertion, load balancer. DFW initially will be provided as a free trial, and then later, once we enable this add-on functionality, this will all be a paid service, advanced services, paid feature. Okay, DFW, service insertion, and load balancer. Okay. All right. So now that we went through intro, use cases, talked about some of the architecture and benefits coming along with that, and also looked through some of the GUI changes, what I'm going to do is dig a bit deeper into the specific features that are coming with this NSX-T SDDC. Okay, and if you look, what I did is I broke this up into 4 different segments. We have functionality we enabled for networking. We have a lot of capabilities we enabled for security and connectivity, and then also operations. So starting with the networking, what we did here is we fully integrated everything into VMware Cloud on AWS console. Before, you'll remember, you had to go to vCenter and configure the networks there, and then everything else was done through the console. Well, we wanted to make it easier to manage everything, and we wanted a single place for all of that. So we put everything in the VMware Cloud on AWS console. So now customers can come directly to the console, and you can see here there's a segment under network, and they can create network segments here directly within the console. They no longer have to go to vCenter, and actually there's no more NSX plugin in vCenter. All of the networking security is now done through the console. So here they can configure the network segments. They can also enable DHCP. We actually have a hidden network segment here running with a DHCP server. So when they're creating these network segments, they can also, if they want, customers can enable DHCP as well. Similar to before, you can create both routed or extended networks. If you create a routed network, your gateway is going to be in the SDDC. It's going to be that distributed component of the CGW, or the T1 router in NSX-T terms. And if you're creating an extended network, basically what you're saying is you're using L2 VPN, you extended that network to on-prem, and your gateway is going to be on-prem. And really, the goal here was ease of operation and access control for all networking operations. So you'll see in security, when I'm talking about security, we have role-based access control as well. So now you can leverage role-based access control and give specific users access to the networking and security configurations under this network and security tab. Okay, another enhancement we made is with DNS. So with NSX-V SDDC, like I'm showing here, you can only configure 2 DNS servers under compute. Okay. Now with NSX-T SDDC, what we're enabling is we are enabling you to have multiple DNS zones, and then within each of those DNS zones, you can configure different DNS servers. Now, in terms of security, a lot of enhancements here, starting with what I mentioned earlier, role-based access control. We provide both NSX Cloud Auditor, which is read-only access to the Network and Security tab, and NSX Cloud Admin, which is read and write access to the Network and Security tab. Now, it's important to note if user doesn't have one of these roles assigned here when you give that user access, they won't even see the Network and Security tab. So they have to have at least one of these roles to even be able to see that Network and Security tab, and then you can decide should they have only read-only access or should they have read and write access. One of the biggest feature requests here was with distributed firewall, or DFW, right? Customers wanted the ability to segment networks. They wanted to be able to do microsegmentation between workloads on the same segment, and also segmentation between workloads on different segments. So now with the NSX-T, SDDC, we have this advanced microsegmentation security. We get two-tier security, both at the edge and at the VM level, right? So we can configure firewall policies at the edge for north-south access, and then we can use microsegmentation within the SDDC to control east-west access. You can have multi-tenancy even with this single CGW design, right? Obviously no overlapping IPs, but the idea here is a tenant could each be on a different network segment, and then you can use DFW to provide isolation or segmentation, right? So you can easily isolate networks like prod, test, dev, or different tenant environments. You can easily create DMZ zones, and one of the most important things here is customer can now migrate workloads to the cloud and get the same level of security that they're used to on-prem, right? So if they're on-prem leveraging things like security tags, security groups, well, we're now also providing that functionality in VMware Cloud on AWS. So they can leverage the same tools and capabilities that they're already leveraging on-prem. And here you can see basically this is a GUI of distributed firewall. On the left here you can see we have a grouping construct, emergency rules, infrastructure rules, environment rules, application rules, and then a default rule. So idea here is we had a lot of feedback from customers on making this rules easy to find and manage and configure, right? So let's use an example here. Let's say we have a web server and there's an emergency and we need to block all access to that web server. Well, customer would come to this emergency rule group and create that emergency rule here where they'll say block all access to this web server, and when the issue is resolved, they can go back and either allow access or simply delete that rule under emergency rules. So it makes it easy for customers to manage these policies and easily find them later. So emergency rules are just like I explained for emergency type situations. Infrastructure rules are for things like access to vCenter, basically infrastructure level rules. Environment rules are higher level rules such as perhaps, prod can access test, the test can access dev, and so on. Rules kind of like at a higher level. And then application rules are more specific granular rules, perhaps even rules within the same application. For example, web can access app tier, but app tier can't access database tier, and so on. And within each of these groups, user can create multiple sections and then have multiple rules under those sections. And the rules are hit from top down, which makes sense, right? So emergency rules, the infrastructure rules, environment rules, to finally more specific application rules. Now, there's also edge firewall, as I mentioned, and with edge firewall, we have both CGW firewall and MGW firewall. So talking about CGW firewall rules first, here what we did is we implemented this, instead of on the CGW, we implemented this on the tier 0 router. And we did this for several reasons to provide, you know, a couple benefits here. Let's say we had a web server that's sitting behind the CGW. Well, if we configure the CGW rule directly on, or if we configure this firewall rule directly on the CGW, we block access to that web server regardless of what interface that traffic is coming in from, right? With this model, what we're doing is we're actually applying those rules on that tier 0 router on those interfaces. So customer could granularly select, hey, you know, put this firewall rule on the internet interface, VPN, Direct Connect, or the connected VPC. So for example, what they could do is say, okay, block access to this web server on the internet interface, but allow access from on-prem over the Direct Connect interface. It can be very granular in terms of where they apply these specific firewall policies. Okay. Another example here is, let's say we have a monitoring app here sitting on a network segment behind the CGW, which needs to access vCenter. So here, what will happen is, you know, the traffic will come from this monitoring app to the CGW. Again, it'll hit the tier 0. There's no firewall policy here, so it'll just hit the tier 0 and come down to the MGW, and access to all management components here are controlled in one centralized place, the MGW, because of this model. So customers can simply come here and configure what should and shouldn't have access to those management components. Okay, so there's two benefits, again, to this model: that very granular selection of where to place that firewall rule in terms of interfaces, and then also the centralized management of these firewall policies for the vCenter management network. Okay. So here I'm showing GUI for the edge firewall, starting with management gateway. Again, this is where my management workloads sit behind, and you can see in source and destination, I'm using security groups. Okay. Now, if I edit one of the rules and look at the sources, there I'm just selecting a source. You can see I have both system-defined and user-defined rules. And the system creates automatically a number of groups for you, like vCenter, NSX Manager, and ESXi, because we already know those endpoints, right? So these groups are automatically created, and then you can use them in your rules. For example, if you want to allow access to vCenter, vCenter would be in the destination, right? And then you can just create that rule. You don't have to create this specific security group for vCenter. Similar with ESXi and NSX Manager. Now, user can also create user-defined groups here, and typically these are going to be like some type of you know, components where they're, you know, deploying something on-prem, and these are going to be IP address-based security groups, right? Now, if you look at compute gateway, again, similar model. You have source and destination. You can use security groups. Notice here under the applied to, just like I explained in the prior diagrams, you can selectively select the interface here. So we have some default rules at the bottom that drop the traffic on all uplinks in the VPN tunnel interface, but then you can create separate rules on top and select the interface. For example, here I have VPC interface, where I'm saying workloads from my app network segment can talk to the my work EC2 instances in my connected VPC. You can see here we also have some system-defined groups, like connected VPC prefixes is automatically created, because when you set up that connectivity, we automatically learn all the subnets. We know the subnets in the connected VPC, and we create a security group out of that. So here, if I edit this rule and I click the sources, you can see there's a number of security groups created. Some are user-defined, some are system-defined. These can be both IP address-based and also based on other criteria like VM name, security tag, and VM instance. Okay. So the grouping objects you just saw, where I kind of explained at a high level, what's supported here? Well, we support IP address, VM instance, matching criteria, VM name, and also matching criteria of security tag. So here you can see under workload groups, there's a number of security groups already created, right? And you can see some are based off of security tag, others are based off of IP address, okay? And these workload groups, I can use both in my CGW firewall policies and also my distributed firewall policies. In management group, you can see I have a number of the system-defined groups already created, like ESXi, NSX Manager, vCenter. You can see I also created a user-defined group, on-prem workloads, which has the subnet of my on-prem workloads, right? And again, these are IP address based because they're typically, infrastructure components or workloads or components on-prem, which are going to be IP addresses. Okay. So now security tags. We also have support for security tags. You can see if I go to my inventory and groups and I go to virtual machines there, it shows me an inventory of all my VMs in vCenter. And I can come to these three dots on the left here, click Edit, and simply put in a security tag for that VM. So while I'm creating the security tag, I'm also attaching it to the respective workload. All right, so you saw there's a lot of features, a lot of enhancements in terms of security coming with the NSX-T SDDC, also quite a bit with connectivity. So we have a number of VPN enhancements here. Again, one of the enhancements is it's a single VPN tunnel design, where with NSX-V SDDC, you had to have a VPN to your CGW and MGW, and there was no connectivity between them. Now, since you have that tier 0 router sitting between, you create one VPN tunnel from on-prem to that tier 0 router, which then knows how to route to the CGW and MGW. Okay? And a lot of enhancements here in terms of the supported attributes. I'm not going to go through line by line of each of them, but we have enhancements in terms of what more we support in terms of encryption, encryption and so on. But the important thing to note here is in terms of the VPN type, with NSX-V, we only supported policy-based VPN. Now, with NSX-T SDDC, we support both policy-based VPN and route-based VPN. So what this means is you can set up IPsec VPN, and then on top of that, you can configure BGP. So what you'll do is you'll configure a VTI virtual tunnel interface, and then with that virtual tunnel interface, you'll run BGP to on-prem over to IPsec VPN. And there's a couple benefits and advantages here. First, it provides redundancy. So you can set up VPN tunnels to 2 different on-prem edge devices, right? And both of those tunnels are active, right? But you can use BGP metrics like MED to control which one's going to be active and which is going to be passive in terms of data flow. Okay. The other benefit is networks are automatically learned from VMware Cloud on AWS and vice versa via BGP. So unlike policy-based IPsec VPN, you don't need to go in there and manually configure each network, right? So it's also less error-prone and no additional configuration required when advertising new networks. Okay. So here you can see an example where I'm showing route-based IPsec VPN, where, here I have the remote public IP, where IPsec VPN will terminate. And then under this VTI prefix length field, what I did is I put in a /30. And again, this is that VTI interface I was talking about. So what actually happens there is loopback address gets created on the tier 0, and you're going to use an IP address within the same subnet on-prem, and this VTI interface is going to be used for doing that BGP peering. Okay. So if I click this set BGP neighbor here, I can put in the IP address that's on-prem. You can see it's in the same subnet that was in the previous field under VTI interface. It's in the same subnet where BGP peering is happening. And I can put in that BGP neighbor AS as well. Okay. So here's my local AS number I put in, and then I can put in my peer AS number. And then what will happen is BGP will get established, networks will already automatically get learned, and then on top of that, you can see this once the VPN is set up, we provide statistics as well to let you see if there's any issues that are occurring after that initial VPN is configured and set up. Okay. Some additional enhancements we did with Direct Connect. So as I mentioned, NSX vSDDC, you could use Direct Connect private with, but only ESXi management, vMotion, cold migration traffic was supported over this, and then for all other traffic like compute and management appliance traffic, we had to set up VPN either over internet or Direct Connect public with, right? So it was a bit more complex, and what customers really wanted was to carry all traffic over to Direct Connect private with, which terminates directly into the VMware Cloud on AWS VPC. Okay. So now with NSX-T SDDC, we actually support that. And again, this was a limitation with transitive routing on the AWS side. So what would happen is when traffic came over this Direct Connect terminates in VGW that's sitting within VMware Cloud on AWS SDDC. That VGW didn't know how to reach those NSX network segments, right? You can look at these NSX network segments and these networks behind both CGW and MGW as separate routing domains, right? So basically, it was only aware of the VPC, native VPC CIDR. It wasn't aware of these network segments and these other routing domains. So what we did to fix this transitive routing issue is we actually have an agent that updates the route tables in VGW to inform it how to reach these other NSX networks. Okay. So now we support all traffic over this Direct Connect private with, including workload traffic and appliance management traffic. Okay. Now, there's also some enhancements in terms of connected VPC. Okay, so on the left here, you're seeing the topology with NSX vSDDC. On the right is with NSX-T SDDC. And what you'll see here is, again, now we have the tier 0 router sitting between the CGW and MGW, whereas here the connectivity was pretty much going up to the CGW, right? So one benefit here is, as I mentioned early on, we update the route tables in VMware Cloud on AWS, so it can now reach both the CGW and the MGW. Again, it's all going through this tier 0 connectivity. Okay, so we update the route tables of the native AWS account to reach the compute workloads and the vCenter management network, which is now also on an overlay. Okay, and finally, let's look at operations there. Quite a bit we did here as well. So first, NSX-T APIs. We offer both the public endpoint, this is a public IP address sitting on the VMC console, which can be accessed to call NSX-T APIs. And then we also provide private endpoint. So let's say you have Direct Connect or VPN set up, you could use private IP address to call these NSX-T APIs for both day 0 automation, where you're initially setting up stuff on initial deployment, and also day 2 operations for things like, let's say, you want to create additional security policies and so on as you onboard different tenants. Okay. Now, operational tools. We leveraged that functionality I showed you earlier, where now network segments or workloads sitting on network segments behind the CGW can access the vCenter management network and ESXi hosts, right? So here I'm using that functionality, or we're using that functionality to enable these additional operational tools and these capabilities. Starting here with port mirroring, where you can see we have a port mirroring feature under tools, where I can go and set up a port mirroring session. So here under source, I've basically selected a web security group, okay? And for destination, this is a web server sitting in it. And for destination, I have a Wireshark security group. which is basically consisting of a workload, a Windows workload that's running Wireshark. And I've set up directional as bi-direction. So traffic coming in and out of this web server within the security group is being port mirrored to this Wireshark sitting on a network segment behind the CGW. You can see here the status is up. Okay. Another capability under tools is this IP fix. So I can now set up something like I mentioned earlier, Plixer Scrutinizer on a network segment sitting behind CGW. Then I can come here, set it up as a collector. Then I can create a specific session saying, okay, for my network segment web, basically I want to send this IP fix data, this flow data to my scrutinizer, Plixer Scrutinizer sitting on that network segment. I can create a session for that, okay? So you can see there a lot of functionality that's coming with this NSX-T SDDC. So what I want to show here is basically a demo that brings together a lot of what we discussed, really focusing on the security aspects. So here I'm going to show a demo where I have an on-prem environment, then I have my VMware Cloud on AWS SDDC. You can see here behind CGW, I have a 3-tier application, web, app, database with these respective IP addresses. I also have a network segment running a Windows VM, which is running Wireshark with this IP address. Okay. Then we have my MGW. These are all the components that VMware manages. And I have direct connectivity to on-prem. And you can see on-prem, I don't have any NSX running here, but I have, I have a couple networks created, VLAN-based networks, and I have a workload running with this IP address, which I'm going to use in this demo to show some of the communication. And then I also have connectivity to my native AWS services where I have things like EC2 instances running. So now when this direct connect is established, what's happening here is the infrastructure subnet and my network segments are automatically advertised to on-prem. And from on-prem, I'm advertising default route to the SDDC. So first thing I'm going to do is from my one of my on-prem workloads here, I'm going to access vCenter over this direct connect. I put in the policies to allow that communication. I'm going to access vCenter to access the console and do some configuration. Next, what I'm going to do is I'm going to show communication from my web server to my database server, and then I'm going to put a DFW rule in place to show that microsegmentation capability. What I'll do next is from on-prem, I'll communicate to my web server sitting in my VMware Cloud on AWS SDDC. Then I'll put a firewall rule placed directly on that direct connect interface. Okay. And then what I'll do is I'll access from my app VM sitting here in this SDDC, I'll access my EC2 instance with this IP address sitting in my native AWS account. And then I'll put a firewall rule on that connected VPC interface to block that communication. And then what I'll do is I'll allow that communication and I'll port mirror that traffic to Wireshark to show the port mirroring functionality as well. Okay, so a lot going on in this demo. So let's get started here. First thing, here's my SDDC. I go to my Network and Security tab, and you can see here I'm going to click Open vCenter, show vCenter credentials. You can see here's my credentials. I can click Open vCenter. To save time, I already have a tab open here, and here's my management resource pool and my compute resource pool. Within my compute resource pool, you can see I have a web server here ending in 31.1 on the web network segment. Here's another web VM in the same subnet on the same web network segment. I have an app VM ending in 31.17. It's on the app network segment. And database, again, ending in 31.33 on the database NSX network segment. Okay. And I also deployed Wireshark here ending in 31.49, and it's sitting in that monitoring NSX network segment I showed earlier. So that's my environment in a nutshell here. I'm going to go back to my console. Under my Networking and Security tab, you can see this is my management gateway, and here's my compute gateway. And then you can see I have different types of connectivity here to internet, to my connected VPC where I have my native AWS services, and then also to my on-prem VI Direct Connect you can see is established here. Okay, so if I go to Direct Connect here, you can see I have 2 private WIFs created. The state is attached and the BGP status is up. So my networks and my SDDC are being advertised on-prem and vice versa. I can come here, you can see these WIFs are attached, and you can see down here under advertised BGP routes, these are all the routes being advertised from my SDDC to on-prem, the infrastructure and NSX network segments, and I'm also learning my default route from my on-prem. Now, under network segments, you can see here's all the network segments I created, including my 3-tier application, web, app, and database, and the respective subnets. You can see at the bottom there's also a default network, and then I also have a monitoring network segment created where Wireshark is running. Now, if I go to groups and virtual machines, you can see here is my vCenter inventory, and I already have some tags attached to my app and database VMs, and you can see here I'm attaching the web tag to my web servers here. So I have 2 web servers, and I'm just creating and attaching that web security tag. Okay. Now, if I go to workload groups again, you can see I have app and database security groups created already based on those respective security tags. I'm going to create a security group for web here as well, and I'm going to base this off that matching criteria of the web security tag. Okay. So here I'm just going to put web equal or tag equals web, and cool thing here is once I create this, I can go and actually click here and say view members and ensure those web VMs are actually picked up. And you can see here they are picked up. They're part of that security group now. Under management groups, you can see here's all those management groups system defined, and I created 1 user defined, and these are IP address based. I'm going to go to distributed firewall here. You can see there's no rules created. There's 1 section I created, but I've created no rules, and the default rule here is allow all. So what I'm going to do is I'm going to go to my web server, okay, and you can see it's that same IP address ending in 31.1, and I'm going to do a continuous ping to my database server ending in 31.33. You can see everything's working here. And what I'll do here is I'll go back to my DFW, and I'm just going to create a rule called web to database. And for the source, I'm going to select that security group based on that web security tag I just created. Okay. So, and under destination, I'm going to select that database security group based on that security tag of database. And I'm just going to drop this communication or this traffic here. I'm going to publish the rule, and I'm going to go back, and you can see that the rule is now applied. Traffic is now being dropped from web to database. Now, if I go back to my console, under groups, you can see I created on-prem workloads with this subnet. The subnet is for all my VMs or my workloads on-prem. Okay. So now if I go to Compute Gateway, you can see from on-prem workloads to any for ICMP traffic directly applied on the Direct Connect interface, I'm allowing that traffic on the CGW firewall, right? So if I go to my on-prem workload in that same subnet here, you can see I'm going to go ahead and just do a continuous ping to my web server sitting in VMware Cloud on AWS SDDC. The T communication there is good as expected. Now what I'll do is I'll come back to this rule, and I'm going to make it a bit more specific where I'm going to change the destination to that web security group based on that web security tag I created, right? And you can see it's still applied on the Direct Connect interface, but I'm going to just change the action to drop. This applied to interface is still Direct Connect. And I'm going to go back, and you can see now that communication over Direct Connect is now dropping. That traffic is now dropping, right? So now what I'm going to do is come to this connected VPC. You can see I have EC2 enabled. You can see here's my VPC ID. Here's my VPC subnet 172.31.32.0/20. And you can see here's my EC2 instance running in my native AWS account. And you can see it ends in an IP address of 34.85. Okay. So now if I go back to my console, you can see under Edge Firewall, under Compute Gateway, I have a rule created called App to AWS Workloads. And the source of that app, NSX Network Segment Destination, is that connected VPC prefix system-defined rule applied to the VPC interface. And this action is allow. So right now, if I do a continuous ping from my NSX Network Segment called App to that EC2 instance running in AWS, you'll see the communication right now should be good and everything should work as expected. What I'm going to do is I'm going to go back to my VMware Cloud on AWS SDDC, and I'm going to change that CGW firewall policy. And all I'm going to do is just drop the traffic. You can see it's still applied to the VPC interface. Source and destination are still exactly the same. I've just dropped it, and now you can see that traffic is being dropped. Okay, so now I'm going to go back to my console here, and you can see under workload groups, I have a group created called Wireshark with IP address of a Windows machine that's running Wireshark. And under port mirroring, you can see I have a session created. Source is app, destination is that security group with that Wireshark VM, bidirectional, and I have this session running. Okay, so I'm going to go back to my app VM, and I'm just going to stop this continuous ping. And remember, this is the source of that port mirroring session. So if I go to my Wireshark VM, now you can see it's that exact same IP address. And what I'm going to do is I'm just going to start capturing traffic. Remember, I already have that port mirroring established in the console. So now I'm capturing traffic on my Wireshark. And in my Edge Firewall, I'm going to go to my Compute Gateway. And you can see it's still dropping traffic here. So I'm going to start allowing it again on that VPC interface. Okay, and I'll publish a rule, and then I'll now start doing the continuous ping again. And I have Wireshark running, so I should now see that communication. And you can see, indeed, I see that communication, from the app VM to the EC2 instance, and I'm doing the port mirroring here. Okay, so pretty cool stuff, and you can see there's a lot of functionality there. I just showed in that demo. So it looks like we're a little bit over on time, but just to wrap up here, in summary, we make, with similarity of vSphere, we make it very easy for customers to adopt cloud. Again, you're getting vSphere on both ends. We enable multiple use cases, data center extension, on-demand capacity, migration DR, everything we talked about, offer multiple connectivity options for a hybrid cloud solution. And with NSX-T SDDC, we provide advanced networking and security services. All the things we talked about, DFW, grouping objects, Direct Connect enhancements, route-based IPsec, VPN, port mirroring, IP fix, etc. Right? So hopefully this, was useful for you, and you have a pretty good understanding of what the features and capabilities that are coming with this NSX-T SDDC and VMware Cloud on AWS. Thank you. Thank you for joining.
Hey, thank you, Humair. That was a great presentation, and thank you, Venki, as well, for hopping on and addressing each one of our partners' questions. And again, I'd like to go ahead and thank each one of our partners for attending our event today. And then just real quick, any questions that you have that may not have been answered on today's session, you can go ahead and send an email to us at vmcisv@vmware.com. You can see there on the screen under tab program that alias vmcisv@vmware.com, and we'll go ahead and work with Humair and Venki's team as well to address any questions that you may have and get those answered for you. And again, just a couple links here where you can learn more on any roadmap items, and you can also follow us on Twitter as well to get any updates. And so thank you again for joining today's session, and thank you to Humair and Venki for taking the time to present and address each one of our partners' questions today, and we look forward to hearing from you all soon. So with that being said, we'll go ahead and wrap up today's session, and thank you, everybody. Thank you, Humair.